The distance formula, number one. Welcome back to virtual class. You can see there's a video link right here. I don't know if this will be here by the time you see it once I put my own link here. This was a link to deriving the distance formula from the Pythagorean theorem. The Pythagorean theorem, one step above it, ends up being the distance formula, where you use the Pythagorean theorem to come up with the formula to calculate the distance between any 2 points on a, well, XY plane would probably be the best way of saying that. So hit preview quiz now. Have your Desmos calculator up on the right, as always. And let me just show you how this works. So number 1 and 2 are intentionally built this way to use the Pythagorean theorem to sort of prove to yourself what the heck's going on here. So you have this problem right here. We're going to solve for this blue line segment. How long is this? And we're going to use the 2 legs of this triangle that's been built on the x and y axes, and where the blue segment is the hypotenuse, to solve for it. So the first thing is count how much the length of each of your legs are. Not your own legs, your human legs out there, your triangle legs. Now, has a bottom left corner at 0, 0, so it's actually pretty easy to see. Like this goes up to 5, and this goes to 10, so it's 5 and 10. But just look, because the next one's not as easy. That means that we have these spaces in between our squares of 1, 2, 3, 4, 5. That's why this is 5. And similarly, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. So then we can remember our Pythagorean theorem, which says if we're finding the hypotenuse, we do the square root of 10 squared plus, not minus, 5 squared. Hopefully by the end of this unit you will get so good with Pythagorean theorem that maybe even if you came into this not knowing what it was used for or how, you're now a pro. So 10 squared plus 5 squared. And we see the distance formula rounded to the nearest tenth again? Yes. So I got to see, is it 11.1 or is it 11.2? My second digit is an 8. Also, hopefully you've gotten really good at rounding to the nearest tenth this unit. We've been doing a lot. Is that 5 or above? Yep. So I give it a shove, 11.2. And there you go. You'll see what I'm talking about for the next one, because now this triangle is stuck where the bottom left corner of this right angle is not at your axes. So you have to manually count. So down here it's 1, 2. Notice how I'm counting not the lines, but the whole little segment in between. This is 1, 2. Okay? So you're going to have to maybe zoom in on your computer and count these segments as well. You could also do this. This bottom is at negative 10. The top of the triangle is at 4. So you could do 4 minus negative 10. You could do your top minus your bottom. That will give you the length and ends up being very applicable in the distance formula. But since my writing utensil does not work at the same time as my calculator, and we know this because I always have to close the writing utensil to use the calculator, I'm going to continue to manually count this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, which makes sense because if I count this 10 and then 4 more, which is another way of doing it, I'll get 14. So then I know the square root of 14 squared plus 2 squared. I'm going to close this to use the calculator in 3, 2, 1, boom. All right. And I love, if this was in class, I can hear it already. Oh, stop, don't close it, don't close it. Well, now as a video, you could close it, you could pause it, you could rewind it. Everybody could be doing different things at the same time. I wish I had done this 9 years before, honestly. That's how well these teaching videos are working for people. And I see it's 14.1. Oh, that's very close to what I had before. 11.2, 14.1. Notice we're not rounding up for this one because we don't have 5 or above. We're not giving it a shove. Okay. Now we're going to use the distance formula. We're going to have 2 points. We're not going to have a graph. And we're going to go from there. So I'm going to pull up some notes right here. All right. And I need to find a way of having these 3 windows open at the same time. So let's make this one smaller. Okay, that should cover it. And then this middle one can stretch like here. And then this other one we can move a little over because I'm not going to need the graph. Like this, maybe? Okay. There we go. There you go. So you could have 3 windows at the same time potentially on your laptop as well. This is what the distance formula is. And notice what it says as a derivative of the Pythagorean theorem. The distance d between the 2 points A equals the point x1, y1, and B equals x2, y2 is calculated or computed using the following formula. And here it is. The square root of, in parentheses, you subtract your 2 x numbers together, squared, plus you subtract your 2 y numbers together, squared. A huge shout out to Chili Math. Not chill math, as I thought it was initially. Chili Math, and it looks like red chili. Shout out to my roots in New Mexico, red and green chili. This is the red chili math. Okay, so here's what this means. On your Desmos calculator now over here, we're going to get rid of what we had inside the parentheses, or inside the square root, and we're going to add exactly what it tells us to down here. So I need parentheses, and I'm going to subtract my 2 x's. So go over, hopefully you have 3 windows, or actually, you don't even need, you only need 1 window, I guess 2 with my video right now. Look at your numbers in your problem, okay? So I have 8, 11, and 5, 2. My first x numbers are the first numbers here. So 8 and 5. So I'm going to do 8 minus 5. It does not matter the order you do that in because you're going to hit squared down here. All right, then let's follow the formula. There's a plus sign in the middle. And then I have parentheses, and I'm going to do the same thing with my y's. So my y's are 11 and 2. So 11 minus 2. And I have to put a squared on that too. It's a long formula, barely fits in. If I make this larger, does it? No. Can I make this? Yes. Okay, so I'm going to expand this out. I recommend doing that too. Make your graph shorter. We're not going to use it here. And now I see that my answer is 9.48. I ignore everything else after the 8. 8 makes that round up to 9.5. As with any of these assignments, the bulk is the explanation at the beginning. Now we have built our system, and we just follow the formula. So on 4, I'm still using this formula the whole time. I'm just going to replace my numbers. My x values now are 12 and 11. And then notice, for the first time, we have negative numbers in my y's. So watch how I type this in. I just come over here. I erase my old number 11, and I just type my new one, negative 8. I erase my old 2, but I still leave this minus in here, and I type my other y, negative 1. And it looks a little weird to have your 2 negatives in a row, but that's fine. Leave them both there if our number is negative after the minus. 7.07, the 0 rounds up to a 1 because 7's 5 or above, so 7.1. I give it a shove. And after you hopefully get number 4, you can just start rolling. Because now you know what to do with negatives, positives, everything. So now my x's are negative 10 and negative 8. And my y's are 4 and 2. As long as you keep your x's together and your y's together, you can do this in any order you want. One x before the other x, one y before the other y. You can even put your y's first, then your x's. Just make sure you keep them together. Ooh, we have one where everything's negative. So my x's are negative 1 and negative 9. And my y's are negative 2 and negative 10. 14.4 does not round up. And this distance formula, you could take a screenshot of that with your phone or something. Oh! I have my first mistake in many a lesson. Let's figure out what went wrong, shall we? Negative 1 and negative 9. Negative 1 minus negative 9. That looks correct. Squared plus -2 minus... Oh, I didn't put the -10. Ah, I put +10. And sure enough, if I had, I'd get that 11.3 they wanted. All right, redo. Just like you guys. In honor of Red Chili website, I had a red error on my problem. Let's redo this one. Still have negatives everywhere. -12 and -6 and -8 and -7. All right, second time's the charm. 6.1 looks like. Were you guys noticing that? I wonder if you're even following along. You don't technically have to. You can just go on your own. But with somebody screaming at their computer, "Stop! You forgot the negative!" Oh, there it is. Maybe. Ooh, negatives all around again. So that makes it easy. I just leave them all in. -2, -7, and -5, -4. I really like this idea of replacing the numbers each time. You don't have to type the square root. You don't have to remember or forget that there's a plus that goes in the middle and a minus that goes on the outsides. That's always a really common mistake. This really helps that. All right, now we have very few negatives, only one. So 10 minus 6 are my x's, and 4 minus -7. And if you're out there somehow listening to this and you don't have a Core Focus website, like my students do, you can always just pause it, see if you can do the problem on my screen at the same time. And thanks for joining. You certainly don't have to. You're not getting graded on this like the students out there are. Okay. And my last one's 6 and 3. And -9. And -4. I feel a little bit like Bob Ross right now. And a -5. And a -4. Or like an eye doctor. Is it 1 or 2? This is 1. And this is 2. Is it better or worse? This is 1, and this is 2. All right, we're so close to being done now. 3 minus -7. As is with most things in life, they're tougher once you get started, but after you build a system that you can use over and over again, it becomes much easier. And I only made one mistake there. Sweet. We're going to finish this attempt. This is going to make, speaking of building structures, our second distance formula assignment that we're going to get even more practiced on this. It's going to make it really easy because you've already explained it. You already know how to do it. 100% on this one. This has been the distance formula #1 assignment. As always, it's been an honor and a pleasure being your virtual teacher away from class, Dylan. So, best wishes on everything. I hope you're safe, happy, healthy, and well. Take care.